In this video, we're going to talk about the Gini Index, which is a statistical measure of inequality that's often used by economists to quantify income or wealth inequality within a population. And the Gini Index is going to be a number that's between 0 and 1. So at one extreme, 0 represents perfect equality. So everyone in the population makes the same income. Now, 1 would represent perfect inequality. That's the exact opposite extreme. And I guess at that extreme, it'd just be one person would have all the income and everyone else would have nothing. Now, in reality, though, for a particular country or particular population, the Gini index is going to be some number between 0 and 1. It won't be at one of those extremes. So, as an intuitive understanding of the number, a lower Gini index is going to indicate more equality or more equal distribution of wealth in the country, and a higher Gini index is going to indicate greater inequality. Now, here's a table provided by our book that lists the Gini index for several different countries. It also has the per capita gross domestic product. Now, notice a few things here. First of all, two countries could have the same Gini index but have vastly different gross domestic product. So, the Gini index is not necessarily an indication of how well the people in a particular country are doing. It's just a measure of inequality within the country. So South Africa has a high Gini index, the highest one here, of 0.63, and that means that wealth is concentrated among a small percentage of the population. But there's a large percentage of the population that is poor in comparison. Now, Germany has the lowest Gini index, an index of 0.27. What that means is that wealth is more equally distributed in that country. Now, you might think that having a low Gini index is good, and generally speaking, that's true. But if you have a Gini index that's too low, where basically everyone in the country makes nearly the same amount of money, well, that might discourage things like innovation and risk taking and entrepreneurship. And so, generally speaking, it's good to have a low Gini index, but there's not a hard and fast rule about what the best Gini index should be. Now, what do these numbers, these decimals, really mean from a mathematical standpoint? The Gini index is derived from something called the Lorenz curve, which is a graphical representation of the distribution of income in a country. So, for example, for 2014, the US Census Bureau reported that in terms of income, the bottom 20% of households made 3% of all income. The bottom 40% of households made 11% of all income, and so on. You can read the numbers. What we're going to do with these numbers, though, is we're going to take them and we're going to make ordered pairs. So 20% is the same as 0.2, and we're going to make the ordered pair 0.20, comma 0.03. Okay, and this ordered pair is going to be used to make the Lorenz curve. And same thing here, we have an ordered pair 0.40, comma 0.11. What this ordered pair means is that the bottom 40% of households make 11% of all income. So we're going to take these ordered pairs, and economists will use what's called regression analysis to find a curve that fits this data. So our book includes this figure here. And notice along the x-axis here, we have percent of families, and along the y-axis, we have percent of income. So this ordered pair right here, 0.40, comma 0.11, that represents what we just talked about, that the bottom 40% of households earn 11% of the overall income. And then we have 0.60, comma 0.26, so the bottom 60% earn 26% of all income. So we have these data points, and you can fit a curve to these data points using regression analysis. And this curve is called the Lorenz curve. Now, this is for the United States. For South Africa, the Lorenz curve would be a little flatter down here, and it would go out and then up here like this. The Lorenz curve would look something like this for South Africa. Now, for Germany, where it's more equally distributed, it would look a little closer to this red line. Now, this red line is called the curve of absolute equality. So basically, if everyone made the exact same amount of income, the curve would look like this. So basically, the bottom 30% of individuals would make 30% of the wealth. The bottom 40% of individuals would make 40% of the wealth. So your Lorenz curve would just be y equals x. If it was perfect inequality, then you just have a flat line down here, and then you'd have this one individual that would make 100% of the wealth up here. So it'd be a flat line, and it'd be discontinuous. It'd be a point up here. But the closer the curve is to the red line, the more equal the distribution of wealth, and the farther the curve from the red line here, from this line y equals x, the greater the inequality. So, how could we measure that? Well, what we could do is we could find the area between this red line and the Lorenz curve. And that area is the Gini index. Well, really, for technical reasons, we double that area, and that's the Gini index. Now, the reason that we double the area is because we want our Gini index to range between 0 and 1. And if we didn't double the area, well, the index would range from 0 to zero point 0.5 because the area of this triangle right here is actually 1/2. So this is 1 by 1. The area of this is 1/2. And so the most unequal you could have would be an area of 1/2 here. So we double them to make the most unequal be 1.0 rather than 0.50. So the Gini index basically just takes this area and doubles it. Notice that a country that is very close to being equally distributed in terms of its wealth will have a very small area between the red line and the Lorenz curve. Okay, it'll have a small Gini index, whereas a country that had very unequal distribution of wealth, it would have a very large area here, so it would have a very large Gini index. Now, what is the area between these two curves? Well, the area between two curves, remember, is just the integral. Well, in this case, it'll be the integral from 0 to 1 of the top function minus the bottom one. And the top one is just x. The bottom one is this Lorenz curve. This, we'll call it f of x. So our book has this definition. If y equals f of x is the equation of a Lorenz curve, the Gini index is just the integral from 0 to 1 of x minus f of x dx, and then we double it. And the Gini index is always going to be a number that's between 0 and 1. And remember, a Gini index of 0 indicates absolute equality. All people share equally in the income. And a Gini index of 1 indicates absolute inequality, so where one person has all the income and the rest have none. So let's do an example. Using data from a nation's census, an economist produced the following Lorenz curves for the distribution of that nation's income in 2014 and in 2024. And we have these curves, f of x equals x to the 1.7 power, okay, in 2014. And the country in 2024, the Lorenz curve was given by the formula g of x equals 1/2 x plus 1/2 x squared. Find the Gini index for each Lorenz curve and interpret the results. Now, I've actually graphed the curves here in Desmos. Here's f of x equals x to the 1.7 power in blue. By the way, notice the Lorenz curve has to go through 0, 0 because the bottom 0% of people will make 0% of the income. It also has to go through the point 1, comma 1 because the bottom 100% of people have to make 100% of the income. So any Lorenz curve is going to have to go through 0, 0, and 1, 1. So notice in 2014, this was the Gini index, 1.7. And in 2024, they modeled it by this black curve here, 1/2 x plus 1/2 x squared. Now notice in 2014, we're going to have a bigger area between these two curves. The curve is more out here and less close to y equals x. And so we have more income inequality in 2014, whereas in 2024, it has become the curve has become closer to the curve y equals x. We're going to get a smaller area here. And so there's more equal distribution of income in 2024. So let's actually do the calculations. What's the Gini index in 2014? Well, in 2014, the Gini index is going to be the integral from 0 to 1 of x minus x to the 1.7 power dx. And then remember, we have to multiply it by 2. So if we work out the details, we're going to have 2 times, well, the integral of x is x squared over 2. Remember, x to the 1. The integral will be x squared over 2 minus the integral of x to the 1.7 is going to be x to the 2.7 over 2.7. And we're going to evaluate this from 0 to 1. So what we get is 2 times, well, when we plug in 1, we're going to get 1 squared over 2, that's 1/2, minus 1 to the 2.7, which is also 1, over 2.7, minus, and we plug in 0, we're just going to get 0 minus 0. And when I plug this into a calculator, I got this decimal. And if we round to 3 decimal places, this would be 0.259. And notice that's a number that's between 0 and 1. That's the Gini index for the country in the year 2014. Now, what about 2024? Well, we're going to do the same thing, only this time our function was 1/2 x plus 1/2 x squared. So we're doing x minus 1/2 x plus 1/2 x squared. Make sure to put that in parentheses. And when we work this out, we have x minus 1 half x. That's just going to be 1 half x. And then we have a minus 1 half x squared dx. Okay, so we had the x minus 1 half x that gave us positive 1 half x. And we still have this minus 1 half x squared there. Okay, now doing the integral of 1 half x to the 1 is going to be 1 half x squared over 2 minus, this is going to be 1 half x cubed over 3. And we're evaluating from 0 to 1. Now, before we plug in the 0 and the 1, let's simplify this. This is x squared over 4 minus x cubed over 6, evaluated from 0 to 1. When we plug in 1, we're going to get 1/4 minus 1/6. And then we're going to subtract what we get when we plug in 0. Well, when we plug in 0, we're going to get 0 minus 0. So our final answer is going to be 2 times, well, 1/4 minus 1/6. What's that? Well, this is really 3/12 minus 2/12. Right? We get a common denominator. So we have 2 times 1/12, which is 2/12 or 1/6. Now, as a decimal, this is 0.16 repeating, or about 0.167, rounded to 3 decimal places. So what does that tell us? Well, this number is smaller than our number that we found in 2014. In 2014 is 0.259. We have a smaller Gini index in 2024. What that means is that in 2024, wealth is more equally distributed within that country. Okay, so that's the Gini index. And notice how it's using this concept of the area between curves. So we're having to use integrals to calculate the Gini index for a country.